Hey, welcome back. Now that we've seen step one of this process, where we select elements, we saw a bunch of different methods that we can use to select elements. Once we have selected them, we usually want to do something with them. Instead of just putting them in variables for no reason or console.logging them, typically we manipulate them in some way. Manipulation it's not exactly the best term because sometimes we are manipulating the elements. We might be changing their styles. We might be inserting a new element inside of them. We might be removing that element. But other times we're just accessing data. And I wouldn't call that manipulation. We're just trying to figure out what is the contents of this div, or what number did the user just click on, or what information is in the form. That is more accessing, and we're also going to cover that in this section. So manipulation is just the umbrella term. The unfortunate thing about the DOM is when you're learning it, you take a look at any document or any element that you select, there are so many properties, so many methods. As we've already seen a couple times, it definitely can be overwhelming, but we're going to narrow it down to some of the most important methods and properties you need to know. And these are the ones that more than 9 times out of 10, probably 48 times out of 50, I guess I could reduce down. Let's just say most of the time you end up using these methods. These are the methods and properties that we use to style elements, to create new elements, to change attributes, to add a class to an element or remove a class. There's so many different things that we do. This subset of methods and properties, what do we have, like 18, maybe 20? This subset is the majority of what you'll need to make most projects and to get by using the DOM. So in this section, we're going to just take these piece by piece. We're going to start in this video by talking about accessing text from an element. How do we get the contents of an element? So we're going to focus on this corner here, inner text and text content. All right, so I'm working with the same dummy web page. It doesn't matter. I'm just doing something simple, but this applies to any web page you could open. We could do it on MDN. We could do it on Wikipedia, on Facebook. Although I just wouldn't want to show you my Facebook account, but we could. We open up the console, or we run code from a script where we select an element. So why don't we start there? Let's select this H1. So how do we select it? Document, dot, and we have a bunch of options, but I'm going to do query selector. There's only one H1, and I want the first one anyway. So we'll do this. We'll save it to a variable, const H1, and the first property we'll see is called inner text. So inner text is going to give me the text that is in between the tags, right there. So here's the opening H1, here's the closing. Inner text is this right there. So that's how it behaves on a simple element like an H1. But what if we have content nested inside? Let's see if we have a good example of this. Scroll down. We do have this UL. If I were to run ul.innerText, let's see what we get. So I'm going to select the UL with my query selector on UL. There's multiple actually. So we'll just take the first one because all the ULs have LIs inside, and then we'll call this variable UL. So if I do ul.innerText, here's what we get. First thing, second thing, third thing. So this was the UL that we selected. You can see it highlighted when I type UL in my console. And the text that was located inside of it was nested. It's not a direct child of the UL. It's inside of an LI. So we have carrots, we have peas, we have broccoli, or actually we have first thing, second thing, and third thing. They're not directly located in the UL, they're first inside of an LI. But when we use inner text on an element, we get all of the text inside of it. So we could also do this, document.body, which is a reference to the entire body. We don't have to do query selector of body, although that should work. I've never done that before, but I'm sure that does work. Yeah. But we have a shortcut, which is just document.body. It's a property that's always on the document. And if I do inner text on that, we get all of the text from my web page. It doesn't matter how many elements deep it is, if it's buried or nested down, it extracts all the text. So this is the text from my web page. Now, reading inner text is great. That's useful sometimes. But also, we can change elements. We can manipulate the text. It's just another property on an object. And if we change it, the browser is going to update to reflect that. So we have our h1.innerText. If I want to change it, I can change it to, how about, I'm hungry. Let's do double quotes. I'm hungry. And there we go. It updated. Now this change obviously is in the console. It's not permanent. If I were to refresh my page, it's gone. I could add it to a script like I have over here, and then it would run each time and I would see it. But it's kind of silly to update the inner text of an H1 as soon as the page loads. Why not just update the HTML? But that's where events come in, where we can update something based off of an event, a user clicking, a hover. For now, we're just learning the basics of changing elements. So that's the basics of inner text. If I were to do something like document.body or any element, let's do the UL. ul.innerText. Remember that the UL has nested content inside. It has LIs, and this text is coming from the LIs. If I do ul.innerText equals I am a big UL, and I hit enter, all of that stuff is gone. So what we had originally was this. We had a UL with 3 LIs. When I change inner text, even though the inner text we see is only this, we're not seeing those elements. When I set inner text on something, it just puts the text right there. So not a great idea to do that if you're actually trying to preserve the content you had before. But we can use this when we're trying to update, a heading or a caption, or if we just know that there's not content inside that we're going to lose. Now there's also a second property we can use to access the inner text or the text content of an element, and that property is called text content. So on the surface, it seems exactly the same as inner text. If we select the H1 again, I'm going to scroll up. I refreshed the page, by the way, so we lost the change when it said I'm hungry. But if I look at h1.innerText, it's my web page, h1.textContent, which is the other property we're about to see. We get the same thing. So it seems like they both are identical. I can set text content. I'll change this to I am not hungry. And it updates. Okay, same as inner text. But now let's work with this paragraph here. This paragraph has an ID of main, and for some reason it's spaced really oddly. Some of this stuff is on separate lines. Let's say that I'm going to leave that. I'll indent this here. I'll add an extra return. Let's save. I'll format it oddly like this, and I'm also going to add in a script tag. Not that you really should put a script tag inside of a paragraph, but I'm going to illustrate something. I'll put a console.log here. Hello, everyone. And save. So now we have our formatted HTML, or our formatted text with some weird returns and indentation, and then we have a script tag. Let's refresh the page. Let's select that paragraph. Here's our console.log. Hello, everyone. So we'll do a document.querySelector of, it's the ID of main. We could also do getElementById. Save this to a variable. I'll call it p. And let's look at p.innerText. Okay, so it's purely the text, no formatting. We don't get anything about that script. It's just the text. Now, if we look at p.textContent, okay, so it has the same text, but it also has that spacing. It knows about the returns we had in there. It knows about this script text. So it doesn't include the script element or the tags, but the text in there is considered text. So that's probably not ideal, most of the time at least. And we end up getting it all with text content. So that is a significant difference. Also, if I had something that was hidden in this paragraph, a good example would be if I added a bold tag maybe, or a span or some other tag. Let's do a bold tag around some of this content, like that. And then let's say for some reason, I decide to do an inline style just to make it easier. I'll say display none. So we should not see this phrase here. Whatever, presentium autem. If I refresh, it's gone. We don't see it showing up here. But if I run those same lines, I select P, I look at inner text, it's not here. Now if I do the same thing with text content, it's right here, presentium autem. Same thing with our console.log. So inner text is going to be aware of what is actually showing up on the page. For example, our script text does not show up. Nobody sees this in the browser window unless they open up the inspector or the DevTools, versus with text content, it doesn't care at all. It just gives us the inner text of that element from the actual HTML file. It goes into this element and it just takes all the text it can find, cuts out those tags, cuts out the B tag, cuts out this, and we get the text, including the script text. So I almost always use inner text. It's good to know, though, that text content is faster. Another one of those situations where it really doesn't matter, but, I feel like I should say it. It's such a tiny difference most of the time, it would be imperceptible. But the reason it's faster is because it doesn't have to do any of this stuff where it calculates what's actually showing, what's on the screen right now. It just gives you everything. It vomits it out. So that's inner text and text content. You can use both of them to access the text, but there are some differences, as we saw. And you can use either to update the text within an element. You just have to be careful if there's other stuff in there and you update it using either one, you're going to overwrite what was there before. All right, so those are two new properties, inner text and text content. Next up, we have another property that is kind of similar to inner text and text content. It's called inner HTML, but it has a different name, obviously, and it has a different purpose. So inner HTML is going to return or retrieve not only the text inside of an element, but also all other tags inside of a given element. So if I were to call form, if I select this form .innerHTML, I would get all of these elements. If I were to do form.innerText, there is no inner text here. So let's try it out. I'll select the form. I'll do a query selector, document.querySelector of form. There's only one form. I'll get the first one. I'll save it to a variable called form. And then form.innerHTML. All caps on the HTML portion. See what I get here. I'm getting a string that contains all of the elements inside. So I get everything between those two tags. It could be text, it could be other tags. It all just gets grouped into inner HTML. If I were to try it on one more thing, let's select the first UL we find. I'll do document.querySelector UL, save that to a variable, just give it the name of UL. Not very creative. I do ul.innerText. We saw this in the last video. We get first thing, second thing, third thing. And that's because that's the inner text. It's skipping the actual tags. Now if I do ul.innerHTML, I get all of the content in there. The li and the text, the li, the text, li, and the text. All the attributes are there. Everything that I wrote in the HTML is showing up. And I can use inner HTML to update the insides of an element, the insides, to change the content in between the two tags if I wanted to. So for the form, which is right here, I could do this, form.innerHTML equals, and then just pass in some text if I wanted to. And that entire form now only contains this text. If I go to the Elements tab and I look at the form, that's it. Everything that was there before is gone. I kind of destroyed it, which is usually not what you want to do, but sometimes maybe it is. And if we were just setting text, then I would probably use inner text. But we can also add HTML elements in. The annoying part is that we have to make them a string. Inner text, inner HTML, text content, they all return strings. So no objects are involved here, except for the object that we're actually selecting. I have my form. That's an object, of course. But if I do inner HTML again, and I want to set it to contain some other element, I can pass in a string and write HTML in there. So this is fine for simple elements, but if you're doing something more complex, it can be kind of annoying to type it all as a giant string, and we'll see another way of adding elements later on in this same section. But just to show that it works, let's do inner HTML equals, what could we add inside the form? How about a bold tag? I am a bold tag. Close it correctly. We'll hit enter. Now we have a bold tag in there. So inner HTML allows us to pass in a string containing text, containing HTML elements, and what it will do is actually parse this string and look for those tags. It's going through it and figuring out, okay, what is an element here, what is just text, and then it reflects those changes in the DOM. And now if we look at form, this is getting a bit ahead of ourselves, but if we do a console.dir of form, and if we look at its children, it has a new object as a child. It has a B object. It's an element. So it's not just about setting the text and the browser just inserting that in between the tags. It's actually reading this and creating a bold object, a bold tag object. And that's what we see here. So it does take more time because of that compared to inner text if you're just setting text. But if you need to add elements, you can do it this way. But as I mentioned, it gets obnoxious, especially if you have attributes with quotation marks and you've got to mix and match your quotes. Now with template literal strings, it's not too bad, but still there are other ways of adding elements. We're just not there yet. Now the last thing about inner HTML versus inner text. Let's select the H1. So document.querySelector. I'm just going to stick to query selector for most of this because it's our Swiss Army knife. It's so versatile. We'll save it to a variable called H1. I now have H1. We'll look at inner text. We'll look at inner HTML. Great. If I wanted to add something in to my web page, the first thing I'll show you that we haven't seen, you can do this. You can do plus equals. If you don't want to completely override what's there, you want to keep my web page, and for some reason I also want to add is cool. I'll put a space there because this string will just be added into what is already there. And now we have my web page is cool. Probably not that often that you would do it, but you can. But what I want to show you here is that there is a difference between inner HTML and inner text when you are setting them. When we retrieve them, we've already seen the difference. Inner text does not give you the tags, inner HTML does. When you set them, it seems like you could use either. If I want to add an element into this HTML tag, or into this H1 tag, let's say I want to, I don't know, plus equals a bold tag with a bunch of exclamation points. I could do h1.innerHTML plus equals, and then I'll write my bold tag, and then some exclamation points, like that. Close my quote. And those are, I guess it's kind of hard to tell, but those are bolded. They're part of a heading, but we can trust that they're bolded. If we take a look at the H1, they are inside of a bold tag. Now, if I instead do this with inner text, I'll just add more exclamation points. Sure. What do you think is going to happen? That's what happens. So it doesn't ignore the tags. It just doesn't treat them as actual elements or tags for HTML. It doesn't parse them. It doesn't understand that they are bold tags. Instead, it just takes this entire string and puts it in the element. So we end up with the string of a bold tag. So if you are trying to update HTML, you're trying to add an element with inner HTML, you need to use inner HTML. With inner text, you can't actually create new elements. You can't tell the browser, I want to insert a bold tag or an image. It will just insert the text that you pass in, the literal string. All right, so that's inner HTML. Like I said, there are other ways of creating elements, so maybe not all that commonly used once you see the other options, but it's important to cover. Alrighty. Next up, we'll talk about a couple different properties that I'm just grouping together. They're properties that we can directly access on individual elements. So let's start with a simple example. When we have a form, if we want to retrieve the text in a form input or the values from a form, we have an attribute on those elements called value. So if I go to my form here, I have a couple different inputs. I'm also going to add an input with type equal to checkbox. And let's do another input with type set to range. And we'll give it a min of 100 and a max of 500. So we have a couple different inputs. We'll save. Now let's select one of them or all of them. Why don't we do all of them? Sure. So we'll do a refresh of the page first, and then document.querySelector all this time. Or we could have done get elements by tag name, but I'm going to do querySelector all input. And save that to a variable, const inputs. And let's take a look at one of these inputs. So I'll just print the whole thing out, or return the value, and open one up. If we scroll down, there is a property down under V called value, and it's currently empty. But if I fill in a bear name, like Taco the Bear, and we do the same thing again, I'll have to rerun this. I'll look at inputs one more time, or actually, let's just do inputs 0.value. You'll see it's now Taco. So value is how I can get the value out of this form. Same thing with a password input. If I do inputs of 1.value, yes, I do have access to that text in the password input. those dots are not there for real security purposes. They're there to hide the password from other people, but it's not there to hide the password from your code. It needs to be sent in a request, usually to a server somewhere, so that value has to remain. So we have input1.value. We got the password value out of there. Now what about a checkbox? If I do inputs of 2.value, we get on. And if I check it, it's still on? What's going on here? So let's look at inputs of 2. How annoying. If I specifically call one out, it does the HTML representation. If I look at all inputs and I go to the index of 2 and we scroll down, you'll see we have a different property called checked. So this is a different property we can use for checkboxes specifically. So we get checked as false. So I'll close that back up and we can do inputs 2.checked. So this video is, like I said, kind of just a group of attributes that we can access. So these are HTML attributes because I can change a value from HTML. If I want there to be a value in the form when it loads, I could say value equals, what would be a good name for a bear? Taco the bear, Grizz the bear, how about just Buck, Bubba? I'll refresh the page and that value is in there. And if I reselect the inputs and I look at inputs of 0, not 9, 0.value, it's set to Bubba, and I can change it too. And this is a common thing we actually do, not usually to change the input to be something else like plus equals Bubba the bear. Probably wouldn't do something like this with code and change someone's input, although it's possible. Maybe you're doing some sort of fancy input where as a user types, you're adding spacing in or you're validating it, or I don't know. But usually the way that we change the input value is to reset it to an empty string. So if the user submitted the form and we captured the information with JavaScript by extracting the values, and then we do something with it, which we haven't talked about yet, and events and all this stuff to come, then afterwards we might reset it to an empty string so it goes back to an empty input. Think of a search bar. You go onto Reddit or something, or I don't know, some website that has a single page search. If you type something in, you hit enter, you see some new stuff load, and your search bar usually empties out. Not all searches do that. Anyway, sometimes we can reset the input if we want to by setting its value to an empty string. If we go back to this checkbox again, we saw that if we check it and we do inputs of 2.value, it doesn't change. But if we do inputs of 2.checked, we now get true. If I uncheck it, we get false. So that's how we can use JavaScript to read out the value from text inputs, password inputs, or read out the checked state of a checkbox. What about this slider? This range goes from 100 to 500, I think. And if we do inputs of 3.value, it's giving us 130. If I go up, it's 437. Right now it's set so that the step of the range is 1, I believe, the default. But if we give it a step of 50 and refresh, run our code again, just select all the inputs, and then we take a look at inputs 3.value, it's 300, and I'm now stepping by 50 at a time. So we do it one more time, it's now 450. Okay, so that is value and checked. There's one other attribute that we have direct access to on each element, on each input element at least, which is placeholder. I can change placeholder text, really not that common, but right now the placeholder of this password input says password. If I select that input, which is in my list of inputs from query selector all, it has index of 1. If I do placeholder, I can retrieve the current placeholder text, or I could change it to something else. Placeholder equals please enter password. And there's my placeholder text. It's been updated. All right, so that's how we can work with inputs. We also have a couple other attributes that we can directly access off of elements. Let's add an anchor tag in somewhere in my HTML. It doesn't really matter where. I'll put an anchor tag and give it an href of cats.com/cute, and then some text in here. Cats are adorable. sometimes. Refresh my page. Let's select that anchor tag. So I'll do a query selector of A. Need to add my document.querySelector, save that to a variable, call it A. And let's look at a.href. There we go. Notice, well, this is my fault. I did a relative link. I didn't actually add in www. And a protocol. So we end up with the file protocol because that's where I am viewing this file from. But if instead I add in http://www.cats.com/cute, run it again, select it. Here we go. Now it's a link to a website that may or may not exist. I'm probably not going to click it. And I can also change the link if I wanted to now be http://www.google.com. And if we look at that element, I'll just inspect it. Where are you? All the way down here. We changed that href. It now goes to Google. And if I clicked it, it would take me to google.com, assuming I didn't misspell anything. So that's another HTML attribute we have access to. If you're not familiar with the term attribute, by the way, it's these things here where we have some word equals something in quotes. Usually it follows that pattern. Class is an attribute, ID is an attribute, source is an attribute, alt on an image is an attribute. And for some of these attributes, we have this access like directly on the object for value on an input, as we saw for href, and on images, we can access the source. So if I wanted to change this image source to something else, let me get a new image. I'll be right back. I have a URL on my clipboard now. And if I want to select this image and change it, I can easily change the source. There's a source attribute. So we'll select the image with good old document.querySelector of image. That's the type of tag we want. There's only one on the page, so we'll get the one and only one. Save it to a variable. And let's take a look at image.source. There's the URL that the image is currently displaying. If I update it to this URL I have on my clipboard, there we go, new image, a very cute little cat under a blanket. So that's kind of it. We have these different attributes that we can access directly through the DOM. We'll see in the next video that we have some attributes that we can't access that way, and we have a different mechanism or a different way of changing them and reading them in. So that's coming up next. Next up, we'll see two methods, not properties, but methods, called getAttribute and setAttribute. And these methods do exactly what they sound like. They allow us to access or change the value of attributes on elements. So we've seen a couple shorthand or shortcut ways to access attributes. Some special cases like value or placeholder or source or href that are commonly used have their own shortcut property. But there are other attributes that don't. So we have these methods, getAttribute and setAttribute. For example, on this range input right here, if I select it, const, I'll select using a query selector. So I'll do const range equals document dot query selector, and I don't want to just do input. I'm going to do input and then attribute type equals, I have to use the right quotes in here, type equals range. I'll expand it a bit. So give me the first input where it has the type attribute set to range, and we have that range. And if we look at it, where are you? Right here, we have a bunch of attributes. We have the type attribute. We have min, we have max, we have step. So if I want to know what the max value is for this range, I could do range dot, and then the getAttribute method, which takes the name of an attribute as a string, and I'll type max, and I get 500. If I do min, I get 100. I could also view the type attribute and get range. So that's getAttribute. It's simple. You pass in the attribute you're looking for on the element that you're calling it on, and it gives you the value, assuming it has that attribute. If I try and find an attribute that's not in there, like LOL, it just gives me null. Now we can also use setAttribute. So range.setAttribute takes two arguments. The thing we're trying to set, so I'll do min, and then the value I want to give it. Let's say the min is negative 500. Okay? Now if we look in our HTML, or in the Elements tab, and we inspect that input, we should see that now min is negative 500. And if we play around with the range, let's go all the way down here and take a look at range.value, which we just saw. It's now negative 350. So we are successfully setting that attribute. It's one that we don't really have a shortcut for. We have a shortcut for value. We had one for source on an image and href on an anchor tag, but there are plenty of attributes you may need to change where you need to use set attribute. So that's a couple examples. We also could change the entire type of the input. I could do range.setAttribute and then do type, and then we could turn it into a radio button. Sure, type equals radio. And now we have a radio button there. So we completely changed the type of the input. The variable is still called range, but it's no longer an actual range input. So that's get attribute and set attribute. There are plenty of other attributes we could use with this. Most of the common ones have those shorthands that we saw, but if there's ever something you need to change, I mean, technically you could use set attribute to change an ID. So if there's ever an attribute that you need to update or that you need to access, these are your go-to methods, get and set attribute. Relatively straightforward. Next up, we'll see a group of properties that I'm struggling to come up with a name for. They're all kind of, I guess you could say, traversal or neighbor properties. It's a way of accessing the parent or the children or the nearest sibling of a given element. So it's this group right here, parent element, children, next sibling, previous sibling. They allow you to access other elements based off of the current element that you're working with. So this is actually surprisingly common. You don't do it all the time, but there are situations where, especially when we get to events, when a user might click somewhere, and based off of that click, you'll have an element selected, and you want to then select some other element based off of this element. If I was making a, what's a good example here? Let's say I was making a checklist, and I had checkboxes in here. The click would occur on the checkbox, and if I wanted to delete this entire li, I would need to access the parent of the checkbox. Or if I wanted it, for some reason, I wanted to delete this entire form when I click on submit, I would need to select from that button, I would need to access the parent. Or there's plenty of other things we could do, you know, where we're accessing the next sibling. So these would be siblings here. So I'll just show you how they work. Let's take a look at any given element. Let's select something that has some siblings and some parents. Let's go for this li, the very first li on the page. So document dot our good friend query selector li, and save that to a variable. We'll call it first li. Okay, so we have first li, and from there, if we just inspect it, console.dir first li, you'll see that we have some properties. The first of which we'll see is called parent element. LMNOP. Here we go. Parent element is referencing a UL. That parent UL. We selected this li right here. The parent is that UL. So this is a connection pointing upwards. This is how we can find the parent from a given element. I don't know why I just closed that. I meant to just hide this. Okay, so I could access it by li.parent. Do I still have li? Or it's called first li, isn't it? First li dot parent elements. And I get that UL. And if I hover, you can see the DevTools displays the entire UL for me. I also could do first li dot parent element dot parent element again. And what do you think we'll see? The parent of that UL is the body. How about one more time? What if I chain it on again? This time we get HTML. So we went from this li, what was its parent? This UL. What is this UL nested inside of? Well, its parent is the entire body, and this body is nested inside of the HTML. And if we tried one more time, we get nothing. Null. There is no parent of the HTML element. Okay, so that's parent element. You can use that to work backwards, back up the tree, find out a parent from a given element. We also have the opposite. We have children. So instead of using the li, because our li doesn't really have any children, as you can see here, it's just text in there, which actually we'll come back to in a moment. We'll go select, how about we select the UL? I guess it's kind of boring, but we'll select the UL. So const UL equals document dot query selector of UL. We'll take the first one. Okay, so we have our UL right there. I also could have just done first li.parent, but we have our UL. I'll clear my console. If I access ul.children, this is another array-like object, similar to what we get back from our selection methods, and it contains the children elements of this UL. So here's the first one. They're in order of appearance in the DOM. So li with the class of special, then just a plain li, and another li with the class of special. So this is a way of accessing children, going the opposite direction, finding things that are nested inside of a given element instead of what the given element is nested inside of. So our LIs don't really have children, but we could access one of them. If we did ul.children, if I want the first child, I could do of 0. And now I'm working with that li. And I could do something to it, right? I could access inner text. Sure. And we get first thing. Now we also have a couple different options. We have next and previous siblings. So what if we select the li that we have? It's called first li, right there. The very first li that was from earlier. We selected it before the ul. If I accessed first li.next element sibling, we get the next sibling, which is second thing. If I did one more .next element sibling, we get this li down here. So siblings are on the same level. They share a parent. We also have previous sibling. So if I were to save this to a variable, we'll call this const third li. So third li is this li right here. As you can see when I hover, I could go the other way. Third li dot previous element sibling gives me this li, the one before it. So now we have a way of not only doing parent to get the parent element, we have children to get any children, we have next element sibling and previous element sibling, and with those different properties, we can access whatever we need from a given element. We could work upwards, find multiple siblings away, we could find children, find parents. Usually we don't need to do anything crazy. Because if we wanted to find, within children, if we needed to find something and there was hundreds of children, as we've already seen, we can actually call query selector on an element instead of on the document. So you can continue to search within something. But if you just need the parent or the first child or the next sibling, you can use these nice properties. We'll take a quick break from learning new properties and methods just to talk about how we can use what we've already learned on multiple elements. Everything we've been doing so far is one thing at a time. We've been changing the inner HTML or the value of one input or one div or whatever it is at a time. But often we want to affect changes in multiple elements. And we know how to select multiple elements. We use query selector all, get elements by class name, get elements by tag name. That gives us an array-like object. So all we need to do is iterate over that object and then call whatever method or change whatever property we want. So why don't we start by changing the inner text of all LIs on the page. So we need to select all the LIs. And I'm going to do this in a separate file because it takes a couple of lines. So I have a script, app.js. I've included it at the bottom of my HTML file. And I'm going to select all the LIs. So I need my document.querySelector all. I want LIs. So I'll pass in the string li, and then I'll save that to a variable. Let's go with const all LIs. All these. Okay. Now we want to iterate over all LIs. So we can do a regular for loop for let I equals 0, I less than all LIs dot length, I plus plus, and then we can access all LIs of 0. And we could start by just console.logging all LIs of 0 dot, let's do inner text. Okay, let's see what we get when I run this. So I'll refresh the page. No idea why I did 0. It's supposed to be all LIs of I. Whatever that loop iteration is, we'll access that one and get the inner text. And if we run it, there we go. First thing, second thing, third thing, carrots, peas, broccoli. So if I want to change them all, I can just set their inner text. All LIs of I dot inner text equals, and then this is the hardest part always. How about we are the champions? I don't know why, but we'll just do it. Okay. What happens when I refresh the page? every single li now has been updated. So this is the common pattern. We select a group of things and we iterate over that array-like object using a for loop, or we could easily do a for of loop, which I prefer. For let li of all li's. We will, what should we do? How about li dot inner HTML this time? And let's pass in a string, and we'll say we are, and then a bold tag, the champions. Okay, so now we're setting inner HTML, which means that this will be treated as HTML. It will be parsed and turned into an actual bold element on the page. Let's see if it works. There we go. We are the champions on every single li. So we're overwriting the changes we did here, but this also worked. It's just annoying to have to deal with I, so why not use a for of loop? So we can do things like this. Obviously, we can change styles once we see how to change styles, which we will see very shortly. We can access attributes, we can set attributes, we could do all sorts of things, but the pattern is the same. You select, and then loop, and then do something. Versus what we've seen so far, where we select one thing and manipulate it directly without having to loop. If you have multiple, you have to loop. There's no easy shortcut to just impact all of them at once. All right, so that's it for this video. Next, we'll move on to some other properties and methods. Next up, a really important topic, changing styles using JavaScript. So we could select one element or 20 elements and potentially change their color, their background color, their font size. We could hide them. How do we do that? How do we manipulate CSS properties using JavaScript and the DOM? Well, there's a couple ways. I'm going to show you one in this video. It's called the style property. So every element that we select has a style property. So why don't we select one? How about this h1? Const h1 equals document.querySelector h1. In my CSS file that I have here, I've given all h1s a color of purple and a font size of 60 pixels. So if I look at h1.style, I open this up, we get this massive object, but it looks like everything is completely empty. This is not telling me what the color is. It's not telling me font size. Like if I find color on here, or I could just type it. Where are you? COLOO, come on, here we go. Empty string. Why is that happening? It seems like this should be a representation of the styles on the element. But if I do h1.style.color, as we just saw, nothing is there. So this is the first really important thing to understand about the style property. We can use the style property to change colors or styles. We can change any of those properties, and they will be affected on the page. But if we're trying to use the style property to read existing properties, to read existing styles, it won't work unless those styles are defined inline, which is not really a good idea. We normally don't add inline styles. If I go to my h1, I can style it inline. I could say color is teal. I don't know why I'm doing quotes again. There we go. Color is teal. This is not normally what we'd want to do. We want to separate our styles from our HTML. But if I do it this way and I refresh the page, now I select the h1 again, and I look at h1.style.color, it's now set to teal. So the style property only contains styles that you have set inline, which normally will be pretty much completely empty for every element that you look at. But we can also change the color or any of these styles here using the DOM, using JavaScript. I can now make this, is there a color called Orchid? Yes, there is. Great color name. We get this change. It actually changes it. And if we look at what it does on our element, it now has the inline style. Color is Orchid. If I go select something else, like how about just this paragraph here? So we'll do const p equals document.querySelector, and then I'll just delete this. We want the first paragraph. So if I look at p, it's that paragraph right there. If I do p.style. Well, let's do color again. Color on this one will be white. Okay, so I have it highlighted so you can see it, but obviously it's not easily visible right now. So why don't we change the background color? And the way we do a background color in CSS is this, right? Background-color. Now this is another very important part of working with styles in the DOM. in JavaScript, the property names are camel cased. So there is no p.style.background-color. It doesn't exist. We'll get, oh, well, I misspelled it, but this does not exist because in JavaScript, this is not a valid identifier. You can't name a variable or add an object or a property to an object called b-w. That won't work. Syntax error. So that is why all of the style properties in JavaScript are camel cased. So I could do p.style.background color camel cased. It's set to an empty string because we haven't actually set an inline style. All of the styles we have are coming from our style sheet, and I don't think we have a background color anyway. But if I were to set it to black, now that change takes effect. And if we look at the style attribute, or the style property, we'll see that every single property name is camel cased if it's more than one word. So anytime you see animation delay or animation direction or anything like that, in CSS, those would be dashes in between, kebab case, animation dash delay. In JavaScript, in the DOM, it's all camel cased. It has to be. Otherwise, they wouldn't be valid names for properties. Okay, so again, this is only inline properties that we can read out, but we can set any properties we want. But you have to remember that what you're doing is adding a property to the element itself, adding CSS inline. And there's nothing really wrong with that, but there's a better approach. If you have a bunch of styles that you want to add, if I wanted to add like 10 different styles to one of these elements or to a bunch of elements, with this option, using the style property, I have to do it one at a time. p.style.background color equals black, p.style.color equals white, p.style.font size, we can do that one, camel cased, equals, and how about 40 pixels? So that's 3 separate lines. And if this was something I was doing frequently for some reason, probably not these styles specifically, but on a website, we often have groups of styles that we want to apply to different elements, and we keep sort of a similar theme. We would usually make a class, and that's what we'll get to in just a bit. There's another alternative for styling. So this is the style property. It's useful. It allows you to update styles one at a time. Everything's camel cased if needed, but it is not a good way to figure out what the current styles are on an element. Unless you happen to write all of your styles in line, it's not going to have the values you expect. So there's another way we can get all of the actual styles, and that's what we'll see in the next video. What I'll end up with here is just showing how we can use a loop and manipulate styles inside of a loop as well. So let's change these styles of all the LIs on the page. I'll come over to my file, my JavaScript file, select all the LIs, document.querySelector, li, actually I want querySelector all. We'll call this const all LIs. And then we can loop for let li of all LIs. Why don't we set li.style.color to be some color? Why don't we make a little array of colors actually? So we'll do const colors equals, and then red, orange, yellow, green, blue, and purple. How many LIs do we actually have? 1, 2, 3, 4. We have 6. All right, so we have 7 colors here. Yeah, no, 6. Okay, I'm a moron. We have 6 colors. That works, as long as we have 6 LIs. So if I want to access one of these colors and use it to change the corresponding LI, using a for loop, a for of loop, is actually not going to help me much because I don't have the index. I want to take the first LI out of the 6 and set it to be red. The second LI, set it to be orange. So I would probably use a regular for loop here, or why don't we mix it up and use for each instead? All LIs dot for each, and then we'll write an arrow function. And remember, in our arrow function, we have 2 parameters that we can use for each. We have the element and the index. Why don't we just start by console.logging L and I? See what we get. Okay, so we're getting the LI and then the index here. Now I can use that index to access the color. So const color, we'll just call it color, equals colors of I. And that should now give me a color based off of the index of the li that we're working with. So we get red, orange, yellow, green, blue, and purple. So I'm using a for each just to mix it up. And then in here, we'll access the element, which I think I'll rename to li. It's a better name for that parameter. li.style.color equals this color. Let's try running it. There we go. Red, orange, yellow, green, blue, and purple. So why did those styles win out? Where if I refresh the page, well, I have to comment out this code. Before, they already had a color, some of them, based off of a class. And a class is relatively specific, right? Why did these styles win out? When I changed the color, there was a conflict. This is teal, and I made it red. Why did red win? Remember, this is all inline styles. And anytime you do inline styles, it is extremely specific. It's actually added to the element itself, as we've seen, like we have here, and that is going to win out. It's going to beat any class declaration you have, or any class styles. So that's why those styles end up applying. All right, so that's the style property. Every element that we select, we can read existing inline styles only using the style property, but we can set any properties or any styles that we want as long as we use the correct camel case when applicable, and it will actually add an inline style. So it's not changing our style sheet in any way, it's just inserting an inline style declaration into the individual element. Alrighty. In this video, we'll see a different way of accessing style values. So not to set a value, but to retrieve what the current value is for color or background color or display, position, width, all these different properties we might want to access on an element we couldn't really do using the style property as we saw. For example, we take any of these LIs, we select them. I'll just do document.querySelector li just to get the first one. It has that class of special. If I do .style.color, it's empty. And we saw why that happens in the last video. It happens because the style property only contains the inline styles. It does not contain any calculated styles, any styles from a style sheet, anything from a class, which is what's going on here. We have a class of special that is turning this li teal. So if I want to get that calculated or computed value, we have a method called getComputedStyle. And we pass in an element that we've selected. So I'm going to have to select this li and save it to a variable, or pass this in to getComputedStyle. I'll call this li, and then getComputedStyle of li. And I'll save this to a variable. And this will return to me an object called a CSS style declaration. And if I open it up, what you'll see is a ton of stuff. Keep scrolling down. Here we have key value pairs for all CSS properties. Notice there are actual values here. Most of them are just the default values in your browser. So the default background color is down here, which is, where are you? Background color, RGBA 0000, which is just nothing. The default background image is none. The default background position, 00. Then here's one that we applied, border 1 pixel solid teal, which is coming from the style sheet. Here's the class, special, border 1 pixel solid teal. So you can see that this object that we got from getComputedStyles, if we scroll all the way back up, is actually going to contain all of the properties in CSS for a given element, all the possible properties, and all of their current values. Now, when I say current values, they could change. So if we change something the easy way, using the style object, which we could do li.style.color now equals pink. Okay, now let's look at that style object that we got. I'm going to clear my console. It is not happy with the style object that I had printed out. So we have our styles here that we got from getComputedStyle. If we do styles.color, we now have a different color. This is the color I just set, pink. If I change the li.style.color is now equal to red, and we do styles.color again, now we have the RGB for red. 255 red, 0 green, 0 blue. So this object now that we got from getComputedStyles, I'm calling it styles, will contain all of the current updated styles. And computed means that sometimes these styles may come from a style sheet, sometimes they may come from JavaScript, but we can also have things like a hover style. On my H1, If I add in a style based off of hover, and I give it a color of purple and a font size of 80 pixels instead of 60 pixels, if I refresh my page, I hover, it grows. It's not actually turning purple. Oh, I don't know why it did purple twice, but it doesn't matter because in my index, I had a inline style declaration, and that's a perfect example of why inline style declarations suck. They override everything. So you can write a bunch of styles and they won't work. So it should be purple now. And instead of making it purple again when we hover, let's make it orange. All right. So now I hover, it goes orange and it gets bigger. So what I could do to illustrate get computed styles and the fact that it works on any sort of styles that would be applied, let's figure out the computed color and font size when I hover. Now it's kind of tricky because in order to run that code from my console, I have to be typing over here, although I guess I can move my cursor over here as I do it. So let's try it. Let's select the h1, const h1 equals document.querySelector h1, and then I'll run get computed styles. Let's make a variable called comp styles equals, and then get computed style of that h1 that we just selected. Okay, so let's start by looking at comp styles.color. That's the purple color we have. And if we look at font size, remember we have to use camel case, it is 60 pixels. So already this is much better than using the inline style property because we're able to actually get a value for color and font size versus doing h1.style.color gives us an empty string, h1.style.font size also gives us an empty string. So now if I type my line, let's do comp styles.color, but I'm not going to hit enter. I'm going to hover first and then hit enter. Take a look. I hovered and we got a new computed style value. And now it goes back to what it was before. Same thing with font size. It starts at, nope, not that version. This one starts at 60 pixels. And if I run it again, but first hover and hit enter, now it's 80 pixels. So it's kind of cool. Computed styles is a great way to figure out what's actually going on your page. You can have a whole bunch of styles being applied to one element, but to know what is actually winning, what is actually showing up in the DOM and taking effect, you can use get computed style. All right, so that's pretty much it. Get computed style returns a massive object containing every property that has been calculated in CSS. Next up, we'll see a much better way to add multiple styles at once. So if we go back to our code here, I'm going to make a couple revisions. I'm going to get rid of this hover style. It's quite janky. And we have all these LIs. Why don't we make a fake to-do list? So I'm going to just add in some content. We'll do it maybe here before the form. So I'll add in a UL and a couple LIs. And the first thing I'll do is on the UL, I'll add an ID of, how about to-dos? And then I'll have a bunch of LIs. Each one will have a class of to-do, single to-do, not to-dos. The UL will have to-dos as the class. And then we'll just have some basic to-dos. I know it's not very exciting. Let's go with mow the lawn. And then a couple more things. Maybe milk the cows. And what's one more? Feed the alpacas. And then let's also add in a checkbox next to each one of these. So I think I'm going to revise this. I've changed my mind. I'll fast forward. I'll show you what I do. Okay, so I have 3 LIs, each with the class of to do, and I've added a button inside with just an X as the text. This is what we get. 3 different buttons, 3 different LIs, and they all have a class of to do. So now I'm going to add some basic styles to my to do class. I'll select to do, and why don't we do font size slightly increased, so maybe 30 pixels. Let's see how that looks. Okay, and I'll give them a color of olive, and why don't we just start there? Okay, so I have my 3 to-dos here, each with a button. Now, if I wanted to add some styles to mimic the crossing off of one of these to-dos, I want to turn it gray, so change the color. I want to add a line through effect, which is the text decoration property in CSS. Maybe I want to shrink it down so it takes up less space. Maybe change the opacity. Different things that I could do. If I want to do all of those at once to mimic what happens when you click here or you click on a checkbox, which doesn't exist right now, With what we know, it's totally possible. We can do a query selector to grab the very first one. Let's get that first to-do, which is inside of the to-dos ID, and I'll just get extra specific. We could just do this, but I'm going to get extra fancy so that we select the first to-do class inside of the to-dos ID element. I'll save that to a variable, const to-do equals, and then I can go to work, applying one style at a time. To-do.style.color equals, and I'll change it to gray. Is it E, A? Let's see. Is that working? Okay, so it is gray. Now to give it text decoration, it's the same thing. I just have to pay attention to camel casing. And then the property name or the value is line through. We'll refresh. Is that working? Yep, we get our line through. And why don't we also change the opacity? To-do.style.opacity equals, and maybe 50%. Is that going to work for us? Okay, so now it is extra see-through. I also could have just done an RGBA color, but this is better because we have 3 properties, and as you can see, it's 3 separate lines, 1 per property. And imagine we want to apply 20 different properties, radical changes to one of these elements. This is not very ideal. It's not good at all. So what is the solution? What's the best way of achieving this? Using a class. So we define a class in our CSS. We could call it completed or finished, or how about done? And we'll set color to be gray. We'll set text decoration to be line through, and we'll set opacity to be 50%. So now we have this class that the element does not have, but we can selectively apply it. So I'm going to comment out the individual lines, and now let's apply that class. To apply the class, we've actually already seen one way of working with the class. I think I have my to-do over here. Yeah, so I selected it here. I'm just accessing it in the console. We can use getAttribute. Class is an attribute, so I can retrieve the current class, and I get to-do. I could set attribute like this, set attribute class, and then give it the class name I want to add, or I want to use to set the class, and we called it done, right? Done, yep. So I can do this, and it works. Our styles are applied, but if we look at what happened, and you can see here, the font size changed, that to-do has lost the to-do class. It has the done class, which is what we wanted, but we completely overwrote the to-do class. So not ideal. That's the downside of using set attribute. Set attribute just takes this value here and automatically replaces the current class. So I could do this, to-do space done, to apply 2 classes, and that works. But that requires me to hard code in what I'm trying to achieve. What are the classes? If I have 5 different classes on one element, and all I want to do is add the done class, this is not the best approach. So this brings us to a new property we haven't seen called class list. Now class list is an object representation. It's called a DOM token list. It kind of looks like an array, but it's not. And it contains the classes that we have on this element. And it's not just about containing the classes or allowing us to see them. It also provides methods so that we can do things. If we open this up, we have a add method. We have a contains method. We've got, what else do we have? A toggle method. That one's really useful. And I can call these on the class list. So let's cover up the left side of the screen and pretend we don't know if the to-do currently has the done class or not. So we can still see it. There, it's gone. We don't know if it has it or not, and I want to make sure that it does not have it. I want to remove it. The easiest way is to-do.classlist.remove, and then pass in the class name. And if we scroll up, it's gone. If I try and remove it again, no problem. So this is already a nicer improvement. Using set attribute, I can't just say remove this one part. I have to say here is the entire new class string containing all the old classes I want and not containing done. But if I do it this way, I can just say get rid of done if it's there. Or I could go the opposite. I could do to-do.classlist.add, and it will add done. And if it's there already, it's not going to keep adding it. If we look, it just has one done. But perhaps the most useful part is the ability to toggle a class. So if it's there already, then remove it. If it's not there, add it. And we have a method called toggle to do just that. Toggle done. So it's removed, now it's added. Removed, added, over and over and over. Pretty good. So this is useful. If we were to rewrite this ourselves without class list and that method, it would be kind of annoying. We would have to access todo.getAttribute class and then do maybe .includes done and figure out if that's true or false. So if it's false, then we want to add in done. So we would do todo.setAttribute class, and then we would take the current value, so todo.getAttribute class, and then we would add into that done. This is quite janky. So we're saying I want to set attribute, I want to set class to be the current value of it plus the string done. And now we look at todo.getAttribute class. That works. And then if I wanted to toggle it again, I could do todo.getAttribute class.includes done. Now it's true. So I would want to remove done and use set attribute. It's a nightmare to have to do it. Well, nightmare is maybe an overstatement. It's not great. But if we use toggle, it's super easy. We don't have to care if it's there or not. We just say toggle it, flip it. If it's there, remove it. If it's not there, add it. And notice that it does return true or false. So if the class is currently not applied, right now done is not applied, if I toggle it and it adds it in, it returns true. If the class is already there and I'm trying to toggle it again, it returns false when it removes that class. So to summarize the class list, it's a really, really nice property we have access to because we actually apply and remove and toggle classes all the time. We saw the downsides of applying styles one at a time. It's annoying, for one thing, to have to type them on different lines. We have to pay attention to camel casing, and also our styles end up all in our JavaScript. We're writing basically a style sheet right here, versus if we did it this way with a class, we keep all of our styles together, we write them one time, we put them in the actual CSS file. So it has all of our CSS, and we just pick a name for the class. And then from our JavaScript, we can selectively apply and remove and toggle that class. So we can do it all in a batch. One line right here adds, in our case, it adds 3 different styles, but we could have 100 styles in one class. So this is generally the better approach to change styles using JavaScript, unless you are just changing one thing. You want to change the color, it's a one-off, I don't know, you just want to make something green, or you want to change the font size, or you want to hide something one time, then go ahead and use the style property. But if you're doing multiple styles at once, or you plan on reusing this and styling multiple elements the same way, create a class and add or remove it using the class list property and its methods. Next up, we'll see how we can create elements from scratch and insert them or add them to the DOM. So we could create an image, give it a source, and put it on, I don't know, the beginning of the page, or put it inside of a div. We could create 100 links with different URLs and insert them into the DOM. So here's how we do it. The first step is to make an element, and we have a method called createElement. So createElement is actually really simple. It's document.create, not attribute, createElement, and you pass in a string of the type of element you would like. So if we want to make a, let's do a h2 element, we pass in h2. And that's all we get. It makes an empty element for us. But as we've seen many times so far, this is not what it actually looks like. This is only the HTML representation. Let's save it to a variable. We'll call this new h2. And then let's do our console.dir of new h2. It's an object. So we're making a new element of type h2. And if we take a look at the element itself, we have, let's see, we've got HTML heading element, that's the type of element it is, and we have tag name set to h2, and there's no text content, there's no inner content or inner HTML, inner text, they're both empty. So if we want to put some content in, that's a separate step. All we've done is make an element. So we made an empty h2, then if we want to add into it, we could do new h2. So let's just look at new h2 one more time. It's empty. New h2.innerText equals, what should we put here? I like animals. Sure. Oh, missed my quote. Okay. So now if we look at new h2, here's the representation of it. I can also continue to manipulate it. I can add a class if I wanted to. I would just do new h2 dot class list is probably the easiest way, dot add. And what classes do we even have? Do we have any good ones? We have to do, we have special. Let's use the class of special. Now we look at h2 or new h2, and that's what we got. An h2 attribute of class set to special and the inner text of I like animals. So how do we get it in the DOM? How do we get it to show up? Right now it's completely severed in its own little universe in the womb of the JavaScript console. How do we get it into the real world onto the page? How do we deliver this element? Okay, enough of that metaphor here. What we need to do is select an element to append it to. So we have some methods here. The first one we'll see is called append child. Where are you? Did I put that on here? There it is. Append child. So append child is a method that we call on a parent that we want to append an element into. So if I wanted to append this h2 into, let's go to our HTML. How about we put it in this section here? I will select the section and then call append child on the section and pass in our new h2. So we'll select that section, document.query selector of section, save that to a variable. Okay, and then we'll call section.append child, and we pass in our new h2. This is the new element we've already made, and we're now connecting it into the DOM by saying append a child to the section, and a child just means anything inside of this section. We've already seen the children property. When we append, it will go to the end of the children, so it will append down here. We should see it show up after broccoli. And do we? There it is. I like animals. If we look at our HTML in the Elements tab, scroll down, we have a section. The UL that was already there is now joined by a new sibling, this h2. Let's do a couple more examples. We also have the ability to make all sorts of different elements, so why don't we try making an image? So I have an image URL I'll use here from Unsplash. We'll make our new image, so const new image equals document dot create element, and we pass in image. And if I just do that and I run my code again, let's take a look at new image. Same thing, console.dir image, new image. We can see that it's also an object, of course, for making a new element, but it has a different type. It's an HTML image element, so it behaves differently. We don't have inner text. We don't work with inner HTML because an image does not have an opening and closing tag, but it does have a source. So let's set the source. New image.source equals, and I'll copy this URL I have. You could put any URL there. And now let's append it somewhere. If we call append child again on the section, it will go inside of the section. If we don't want to append it to the inside of the section, I just want it to go at the end of my body. I guess it would go after the script, which maybe isn't ideal, but what I could do is use the body and call append child on the body. Or I could put it inside the form. But let's do document.body.append child, and then we pass in our image. Document.body.append child of new image. It's quite a large image. Oh boy, very large, but there it is. So we could also give it an inline style, say new image dot style dot width equals 200 pixels. Refresh again, much smaller, much more manageable, maybe even a bit larger. How about 300? So this process is really common. We make a new empty element of some type. It's always going to start out empty, and then we fill in the blanks when appropriate. We fill in inner text if we need to. We fill in source or href or classes. We've added attributes. We can do whatever we want. So here's one more example. I have a link for a YouTube video. Let's make a new anchor tag. So I'm going to copy my URL just so I can use it. And we'll do const new link equals document dot create element of an anchor tag. That's the type. And then we'll set the inner text, not HTML, but inner text. Let's go with Mr. Bub's video. So that's the name of the video. Wrong place for that period. Mr. Period Bub's video. Click me. And then we want to set the source. No, the href. Source is for an image. For a link, an anchor tag, we want href. And then let's append it to the page somewhere. How about we select the paragraph, maybe the first paragraph, and we'll add it inside the first paragraph. So const first p equals document dot query selector p tag first p dot append child of new link. Fingers crossed. There, we have a new link right here. It was appended as a child of this existing paragraph. If we click it, by the way, it does open up our YouTube video. So that's the basics of creating elements. You can create them of any different type. You can fill them with content, inner text. You can even use inner HTML if you wanted to. You could even append other elements into each element. So we could create an anchor tag and then create a new empty span or a bold tag and append that to the new link, and then take that and append it to first paragraph. So we're not done with creating elements. We'll actually get a little more practice. We're going to build a little example, something slightly more complex. And I'm also going to show you a few more methods where instead of appending at the end of something, what if we want to insert at the beginning, the first child of an element instead of the last? So that's coming up next. Oh, and if you've never seen this video, oh, Mr. Bubs is quite the character here. He's a very special dog. He does not like love and attention, or he has an odd way of showing it. But this is my favorite. Okay, here we go.
Yeah, I got you. I got this on camera.
Anyway, all right, back to DOM stuff. Next up, we'll see a few other methods we can use to add new elements to the DOM. We've seen append child so far. We'll see other options, and we'll also talk about removing elements. How do we delete something from the DOM? As we saw in the very last video, append child takes a new element, but it's a method that we call on a parent. So to add a new li to this list, I need to select the list. So I could do document.querySelector, take the first, I think it's a ul, query selector of ul. I'll call this parent ul. So I have that, parent ul. I'll make a new li, const new li equals document.create element of li. And then I will set its inner text just to be something like I am a new li. Okay, so we have that. Now, I need to make sure my quotes match. When I do append child, it becomes the last element, the last child of the parent. So parent ul dot append child of new li. That's what we get. And that is useful. Sometimes you do want to append at the end, the last child of an element. But what if we wanted to put it at the beginning? Make a new top to do. Maybe these are ordered by priority or due date or something like that. And I want my new to do to go up here. Or what if I want it to go in the middle? We have a different method called insert before. Now insert before sounds like the way that it would work is that we select a node and call insert before on it. So if I wanted to insert before this li, you might think I select that li and then I call, first li dot insert before new li. But that's not how it works. We actually still have to select the parent and we have to select the element we want to insert before. It's kind of annoying. Not annoying enough that you shouldn't use it, but it's just kind of cumbersome. So if I want to make this li that I have down here, I want it to go up top, above mow the lawn. I need to first select mow the lawn. So I'll make a variable called first.li equals document, and what's the best way to select it? I think it's the very first li on the entire page. Let me just double check over here. We've got, yeah, or it's the first to do on the page. We could do it that way. If you want to get more specific, the first li with the class of to do. And if we look at it, there it is. Okay, so I have all the pieces I need. I have my new li that I've made. Right now it's down here, but I still have a reference to that. So if I move it, it will move from down here. Then we also have the first li I want to insert before, and I have the parent ul. So here is how I would insert my li at the top of the ul. I call parent ul dot, and then insert before. And then the annoying part is we have to say the new thing we want to insert, new li, and where I want to insert it. Where I want to insert it before. I want to insert it before the first li. Okay, so the way it's structured, again, we have to have the parent of what we're trying to insert into, and then we also have to select what we want to insert before, and then what we are actually inserting, and there we go. It's now inserted as a child of parent ul, but it's also before first li. And if I wanted to move it right above feed the alpacas, I need to select that one. So I'll call that last ul, const last ul equals document.querySelector. I'm going to do selector all of li with the class of to do, and then take the index of 2, which is the third one. 0, 1, nope, it's the third one, or it's the fourth one, index of 3, because we inserted this. So that should give me, no, that did not give it to me. Let's see, last ul. Actually, I was wrong here. Index of 3 is only going to work if I actually had 4 elements with the class of to do. I forgot that this one up top does not have to do, so we'll get rid of that and change it to index of 2, but I've already declared this variable, so I'm going to call this last to do. So now I can insert. I'll do parent ul dot insert before, and then I want to insert the new li before the last to do. And there we go. It now is right before the last to do, feed the alpacas. We also have a completely different method that we could use called insert adjacent element, and this one's a bit more complicated. We pass in an element, we have to have a target element, but then we also pass in a position. And this is a string, which might seem odd, but we have 4 choices: before begin, after begin, before end, and after end. So if you imagine that this is our target, we have a paragraph. If we want to insert something before this paragraph, we would pass in before begin. If we want to insert it after, we use after end. And then if we want to insert it as the first child of the paragraph, after begin and before end will be the last child. So let's try this just 1 or 2 times. We can use the same li, I guess. Or actually, let's make a new element. It will just be a bold tag. Or how about an I tag? Document.create element of I. And we'll call this I tag, or yeah, I, whatever. It's not a great name, but that's fine. And then we'll do I.innerText equals I am italics. Okay, so we have our I tag. Now let's select one of these elements. How about the very first paragraph on our page? So that will be document.querySelector p. Save that to const first p. Now I can call first p.insert adjacent element, and then I have to specify where. So if I do before begin, and this method I think is kind of unpopular, mainly because you have to remember these strings, and a lot of the time you just want to insert something as the last child anyway, so you can use append child, and shortly I'll show you 2 other methods, append and prepend. But here we can pass in before begin, and then our new I element. And if we take a look, it was inserted before the paragraph began. So that's a way of inserting something before the paragraph. And I personally think this is nicer, even if you have to remember before begin. It's better than what we did earlier when we had to select the parent, insert before, the target, and then the new element. Let's try the same line, but we'll do after end. Now it goes after the paragraph ends. And if we do after begin, it goes into the paragraph element itself after the opening tag, the beginning tag. It goes right there. And then we have the final option, before end, which will put it right here, before the end of the paragraph. One more time, before end. And there it is. So another option for inserting. I did mention there are two other methods we can talk about called append and prepend. These are newer. They do not work in Internet Explorer, of course, and they're just a little bit simpler than append child, and also there is no prepend child. So append is different from append child in that we can actually insert multiple elements at once. So if I have this paragraph tag, let's see, I have my I still, and I have my new li, right? Nope. What do I, new li? Okay, all caps, or L capital I capital. So we have two elements. If I want to insert both of them into this paragraph, which we shouldn't really just put an li in a paragraph, but if I wanted to, I could use append. So it looks like this, the first paragraph that we already selected, dot append, and then we can pass in I and new li. And now both of them have been appended inside that paragraph. The italics tag was already there, so it kind of looks like nothing happened, but it did happen, I promise. And we also have prepend, which is the same idea, except it will make things a first child. So it still will be a child of the paragraph, but it will go to the beginning of the paragraph. And there we go. If we look, we've got I am italics, I am a new li. They're still inside the paragraph, but they are at the very beginning. So append and prepend are nice. They're short. You don't have to do append child. I mean, you just save a couple letters. But with append child, you cannot insert multiple. If I did append child here, it's not going to be happy with me. We get the one element inserted, I am italics, but the li was never added. It just stayed where it was. So append is cool because you can do that, but it does not work in IE, neither does prepend. Oh, so many different ways of adding elements. Stick with a couple. You don't have to master all of them. Append child is usually good enough. If you have multiple, you can do append. Maybe you can do insert adjacent element. You just have to remember the syntax. You've got prepend. Next, I'll show you some ways of removing elements. All right, if you're still with me, thank you. Congratulations. We've covered a lot of methods. We have two more methods in this video, and that's it for new stuff in this section. We'll then do a quick little project where we get practice creating elements, removing elements, inserting, changing classes and styles, and all of that stuff. And then we'll move on to a new section on events in the DOM. Now, events are really the main course of DOM stuff, of these DOM sections. Events are probably the most exciting, but also the missing piece that we need in order to actually make useful applications and start to interact with our websites. So two more methods, and then a project, then events. So the two methods are remove and remove child. And they do what they sound like. They remove an element that you pass in. They follow the pattern that we saw with append child, where this was the original way of doing it, the older way of appending something as a child, and it's supported in all browsers. But there's a newer method, append, that does not work in Internet Explorer. It's a little friendlier to use, and you can pass in multiple elements. Remove is similar. So we have remove child, which has been around much longer, and then we have remove, which does not work in IE. And if you go to the docs for remove child, it's actually mildly confusing on MDN. You scroll down to look at browser support, compatibility unknown for IE. So I had a feeling this was a mistake. Something is just wrong with the data they have. So on another website that I like called Can I Use, if you look at remove child for IE, it's been supported in pretty much every version of IE that they support on this website. So I have no idea why MDN has a question mark there, but it is supported in IE. So to use remove child, we need to find the parent of what we're trying to remove and find the item that we want to remove. So why don't we remove, let's remove peas right here. So that element is down at the very bottom. We need to select that element, which is in a UL, and it has a class of special. So we need to select the UL parent and the LI. Let's get the parent first. Const UL equals document.querySelector, and we have a couple ULs on this page. What I'm going to do is select the one inside of a section, which should give us that one down there. Let's see, UL. Yep, that one is at the bottom. It's the only one contained inside of a section. Now, if I want to get this one LI that has the class of special, I have a couple options. I could just do document.querySelector, or I could search within the ul.querySelector for the class of special. And this is easy, or easier, because there's only one element with the class of special in that UL. But if I instead did document.querySelector, we have multiple other special classes or instances of special on the page. So it's more work. We would have to then say inside of a section, maybe that could get it. But I like doing this version here where we search within the UL and ignore everything else. All right, so I'm going to save that to a variable, const remove me. How about that? Remove me equals ul.querySelector special. So now we have that element, remove me, and we have the parent, ul. I can call ul.removeChild, and I want to remove the remove me element. All right, so the pattern is the parent, and then remove child, and then the child. And this child needs to be a child of the parent. So I couldn't select this ul and say that ul.remove child of this li. It wouldn't work. Also, when we do remove a child, it does return the removed element. So I can save it. I'll just call it const deleted. If you wanted to do something with it, it's gone now. Peas is gone. And if we look at deleted, we do have a variable here that is an object. It's the actual element that we were working with that we just removed. It's just printing out as HTML, thanks to Chrome's lovely dev tools, which actually are lovely, except I hate this one feature. And then we also have the remove method, which works differently. It does not need the parent node. All we need to do is select the target, the thing we want to remove, and then call remove on that node, on the actual item we want to remove. So if I want to remove the h1, for example, I can select it, const h1 equals document.querySelector of h1. There's only one on the page, and I can call h1.remove. I don't need the parent. If I was doing this with remove child, I would have to say document.body.removeChild of h1. But with remove, it's easier. We don't have to have the parent. It just doesn't work in IE, unfortunately. h1.remove, parentheses, and it's gone. That's it. And that's pretty much it for this video. We can remove using the remove method that we just saw. We've got remove child. You could do this in a loop, of course, if you had a bunch of things you wanted to remove. And that's kind of it. Now we've seen how to create elements, how to append them, prepend them, insert them before things, insert adjacent to things, and remove them. All right, so let's try building something with what we've learned so far. We still haven't talked about events and making things interactive, responding to input, clicks, drops, drags, all that stuff. But we do have the ability to create elements, to manipulate existing elements, and we're going to take advantage of that. So I've included a starter file if you want to follow along, so you can have the initial state. What we're going to build is an NBA score table, like what we have here. Based off of whatever input data we get, we could imagine it's coming from an API. But I've actually hard-coded some game data where we have different games. It's an array. We have an away team and a home team. Each team has the team name, or actually it's the city, not the whole team, points, and is winner. And what I want to do is create a table like this dynamically. So not hard-coded in our HTML, but imagine we had 100 different games, or we had 100 different, well, there's not 100 teams, but a bunch of different teams. We want to iterate over this data and create a table. And we don't know how long it will be. We don't know which cells or which rows will be green versus red. We don't know what the values will be. So we'll create dynamic elements and append them to the page using the DOM. So I live in the Bay Area. We'll be doing Warriors games, and I have named this array Warriors games, but this should work with whatever data you pass in. And eventually we'll see we could connect something like this to an API and get data coming from an API somewhere, an NBA stats or a Premier League or La Liga or whatever the sports league is. We can get information and do something with it and make it visual, show something on the DOM. So what we're going to do to start is ignore the table. Tables are really annoying in HTML. They're my least favorite things to create. I mean, if you inspect the markup here, if you haven't made tables before, you can see just how dense this stuff is. To make a single table, we've got so many different nested rows and TDs and TRs and THs and T-bodies and tables and table headers. It's just, it's a little overwhelming to have to create all of those elements with JavaScript and append them. I think it would bog down the important stuff here. So we're going to start with just a simple list. Each game will be a list. It will have the score. It will have the home team. So we'll start by making a simple list, something like this, where we'll have, let's do it in our HTML file. We'll have a UL, an LI for each game, and the home team will come second. So the away team, let's say it's Houston at Golden State. So we want to display it in the order where we have away team, @ home team. So that will be dynamic. We also want to have the score, have the away team score and then the home team. So let's say Houston won this game 100-94. I want to bold this element here of the winning score. So 100 beats 94. So dynamically figure out which team won or which number is higher, give it a bold tag. And if we look at this right now, it's not very impressive. But then we also want to give a green or red color to this element, depending on which perspective we're looking at it from. And like I said, I live in the Bay Area, so we will be looking at this as Warriors fans. So this element would be red. It's a loss for Golden State, just like we have here. So we have green on the games where Golden State won, but if we went to the table, the corresponding table for the Houston Rockets, it's down here. We have red for that very same game. So different perspective, same data. And we'll start with the perspective of Warriors, or the Warriors. Alrighty, so I'm going to delete this. I think I'm going to start by adding in a UL that I can append my data to. We could also do this dynamically. Maybe that's a better way of doing it. Fine, we'll do it from our app.js. We have our starter data, a simple array with a couple of objects. Each object represents a game, away team, and home team, and then each of those team objects has team, points, and is winner. So why don't we start with something simple? Let's get each team to print out or something like that as an LI on the page. The first thing I'll do is make a new element. So I'll make the container. We can call this, or maybe just parent, UL parent equals document.create element of UL. So that is where we will append a bunch of LIs to. And then what we want to do is iterate over all of these games. So we can do that using a for of or a for loop or for each, but I'll do for let game of, and I called my data Warriors games. No, Warrior games. What did I call it? Warriors games. All right. So for each game, we want to extract home game or home team and away team. They all have a home team and an away team. So let's grab that from the object using our favorite destructuring. Const home team, comma, away team equals game. Game is each individual object or each element in the array called Warriors games. And we could start simple. We'll console.log home team dot, let's do away team. So away team dot team, which is the name of the team or the city actually, or in the case of Golden State, it's not even a city. There is no, as far as I know, there's no Golden State city. Away team dot team and then home team dot team. Let's run it, and in our console, there we go. So we have Golden State at Houston, Golden State at Houston twice, and then Houston at Golden State, Houston at Golden State, and then after the first 4 games, so this is the standard playoffs as far as I know in the NBA, you have 2 games home or away, and then you flip for 2 games, and then you alternate. So that's accurate. We're printing out the correct away team and home team. Now let's start by making an LI. So we want an LI for each game, if that's what we're going to do instead of a table, at least to begin with. So we'll make our new LI. We'll call this game LI equals document.create element LI. All right, so we have that done. Next, let's go ahead and show some of this information. Let's get the first part of the team names showing up. So I'm going to have Golden State at Houston. If Houston is the home team, Golden State is the away team. So I want to take this format, away team at home team, and add that as the inner text on my LI. We'll start there. So game LI dot inner text equals, and I'll do a template literal, display the away team dot team, and then at sign, and then another $sign, curly braces for home team dot team. So that should make me the LI and give me some inner text on the LI, but nothing will show up because we're not appending it. And what does it not like? Line 97. Oh, obviously, not valid JavaScript there. So we won't see anything. We need to append each LI to the UL. We've made our UL. We'll append to that UL. And we have a couple choices. We could do append child. We could also use the newer append method. But in this loop, for each LI, game LI, I'm going to call UL parent. So this is the empty UL I've created. I'm now appending one LI. And then next time through, we'll append a second LI. And it will have some data about the away team and the home team. So UL parent dot append child. I'll do append child just in case some of you are using Internet Explorer, even though I prefer append. And we'll append the game LI. Now, is this enough? Will we see anything? No, we will not, because the UL we created is still not associated with the page at all. It exists in JavaScript. It's an object. It has a bunch of children, but we're never actually appending it to the page. So if I just want it to show up in the body, we could append it to the body. That's fine. Or we could prepend it to the body to make it a little nicer, I guess. That's nothing wrong with that. Put it above our script. So I will select the body, which is easy, document.body. I don't need to use query selector, although I could, query selector of body. Document.body.prepend. If you are in IE, you can just do append child, but prepend UL parent. Let's see what we get here. Hey, there we go. Golden State at Houston. Golden State at Houston. Houston at Golden State, blah, 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 blah. We now have, what is this, 7? Yes, 7 LIs appended to our UL, appended to the body. And none of that is there when the page loads. We're constructing it from scratch. All right, so next, let's work on the scores. What we want to do is, first, we can just display the home team and the away team score. I'll do the same format. So away team.points dash home team.points. And I'll start by making it its own string. So I'll just call this const scoreline equals, and we want to do this in its string template literal just to make it easier. We'll do away team dot, and then we have points, and then I'll just do the dash, and then home team dot points as well. It's called points. Yes, it is. All right, so we have a string now, and we could console.log that string to see the score line each time through. It won't be showing up on the actual page, but here we go. That looks accurate. So what we want to do next is get that in the LI as well. And we have a bunch of different options for how we actually approach this. I think what will probably be easiest is if we just make 2 strings and then set the inner text at once with those 2 strings. So I'll make a new variable here, and I'll call this one const, what do we want to call this? Team names maybe? And then scoreline. And then we can set game li dot inner text, or you could do text content, equals, and then I'll do another string template literal and add in my team names with a space, and then again with the score line. So instead of doing these together in one line, it's kind of ugly to see all of those string template literal brackets and $signs. So I'll break it up into 2 variables with names and then add those in. Okay, is it going to work? All right, looks like it's working. So we can double check. The first game, Golden State had 119, Houston had 106. Let's double check up top. 119 for Golden State and Houston 106. Golden State was the away team, Houston was the home team, and we were displaying it correctly. Golden State away at Houston at home. Okay, next we have a couple choices. Why don't we start by selecting the score that has won, the winning score, and bolding it? Which, do they do that? Nah, they don't even do it on Wikipedia. We're adding in functionality. So we'll show the winning score with a bold tag around it. So we're going to have to calculate who won. And that part's pretty easy. We'll just compare the two. Away team dot points and home team dot points. Why don't we start by cleaning this up a tad? We'll need access to away team dot points and home team dot points for a couple different lines because we need to calculate the winner and then display the points as well and figure out which class to apply. So I'm going to destructure team and points out of each object, so out of away team and out of home team. Now this is kind of annoying because to use destructuring, I would do team and points equals home team, and that works fine. But now I have the exact same thing for away team, and that means I'll have team and points, and then I'm creating another variable called team and points. So we can use this syntax we saw earlier with destructuring if we want to, where we grab a particular value out of an object and we give it a new name. So why don't we call this one home team with an H and H points. So H team and H points, and then away team and away points. Okay. And then we'll use that instead of away team dot team, we'll just do a team H team. And then a points and H points. And nothing should have changed. If everything went well, we get the exact same output. But now we have these variables I can reuse instead of having to access away team dot team, away team dot points over and over. Not a huge change, and also the way my VS Code is formatting this, it makes it look like a lot more work than it actually is. It's only one line, really. So we're going to come down here now and compare the 2 points. So we'll have away points greater than home points. Or we could do the other way around. But if away points is greater than home points, then we know that away team has won, right? So we'll do an if statement here. If that's the case, and if away points does beat out home points, then what we want to do is on our score line, we want a bold tag around A points. And we can just add that like this, not right here, but we can do it. We can wrap away points in a bold tag. So the simplest way to do this is if away points is greater than home points, we'll take score line and just put it here on the same line, or we can do it on multiple lines, doesn't matter. And we'll add the bold tag around the first part, the away points, right here. So we'll put our bold tag, the closing bold tag, and then we could have an else. We'll do the opposite. Const scoreline equals, and we'll move the bold tag over here around H points. And that should work. We'll talk about refactoring this in the next video. We'll see that we could move this to a function. We don't have to declare const scoreline. We're not declaring it twice. Only one of these ever runs, but we don't need to do it this way. There are other options. There's one problem with the way I've written this. See if you can figure it out without running it. It doesn't have to do with the actual data or the logic. It has to do with scope. We're using const. And remember that const and let are both block scoped. So if I define scoreline in here, it's scoped to this block. So I can't use it down here. So to fix that, we can't just say const scoreline like this and not define it and then update it. And the reason for that is made very clear. You cannot initialize a const, or you can't declare a const variable without a value. Const high, that doesn't work. But with let, I can. So that's what we'll do. for now until we write this as a separate function. So we'll say scoreline just exists. It doesn't have a value. Then if away points is greater than home points, this is what scoreline should be. Otherwise, it should be this. And then we'll append it. And right now we're doing inner text, which is not really going to work the way we want. We end up with the B tag just being rendered as text. So we'll do inner HTML. Try again. Aha, there we go. So let's verify 119 is greater than 106. That's correct. It should be bolded. 127 bolded. 126. Awesome. So that's working. The next step is to add a background color. So from the Warriors' perspective, the first game should be green because the Warriors won. The next game should be red because the Warriors lost. Houston won. And we'll do that for each one. So what I'm going to do is create a class. And my class, I'll have two actually. Win, where I'll set background color to be, we could just start with red. I think I want an RGBA color, which will be full red, no green, no blue, but I only want maybe like 0.3 on the alpha channel. So a transparent red. And it looks dark here, but it's because the background of my editor is dark. If we actually saw that color, it's a transparent red. So on a white background, it looks sort of pinkish. And then I'll duplicate this and make a loss class. This one will be similar. Oh, why am I doing red for win? That should be the other way around. I want 0 red, I want 255 green, and 0 blue, and then loss should be red. Okay, so I have those two classes. Now we just need to decide which one to show, which one to apply to the entire LI. Now to figure out if the Warriors won a game, because I'm doing this from the Warriors' perspective, I want the green win class to be applied if whichever object the Warriors are, whichever one has Golden State rather than the Warriors. Golden State is what we're looking for. We'll check if isWinner is true, then we'll apply this class of win. Otherwise, we apply loss. So to figure out which team is Golden State, we can do it in a sort of clunky way. It's not that bad, but we'll check just one of the teams, it doesn't matter, home team or away team, dot team, and check if it's Golden State. So let's try it here. Home team, which we already have that variable, H team that we extracted or destructured, H team equals Golden State, and I'll do this as a ternary question mark, and if that's the case, then the variable we want, I'll call this Warriors. This will be a reference to the Warriors object here. And we'll go with Warriors equals H team Golden State. If that's the case, then the Warriors object should be the home team object. This entire home team. Otherwise, we'll set it to the away team. And if I console.log Warriors right now, we should get the Warriors information each time through. Whether it's away or home, we should still see Golden State, Golden State. Great. So now we've identified Golden State. We have a reference to it. Then we can simply access isWinner. So Warriors dot isWinner is going to be true or false. Now, if it's true, then we'll apply the class of win. Whoops, that should be a question mark. Otherwise, we'll apply the class of loss. And we could save this to a variable, like const class name, and then use that class name. Or I could do it in a single line. I want to apply my class to the game li. So game li dot class list dot add this entire expression, the ternary operator. So we will either add win or loss as a class, depending on warriors.isWinner. And the moment of truth will refresh. Hey, check it out. Okay, so it seems to be working. Golden State at Houston. We have Golden State won, so it's green. Here, Houston won, so it's red, and it's accurate the whole way through. Notice Golden State has 4 total wins out of 7. Yes, they moved on. Great job. Okay. So this code we have right now is kind of gross. Honestly, I'm not very happy with it. And that's okay to get something out on the page, get something working, but I definitely want to refactor this for 2 reasons. One, we should break it up into different functions when applicable. to make it just clean and easy to understand. But also, this is all tied specifically to Golden State right now. What if I wanted to make a different table with the same data from the perspective of Houston, and I wanted to append it down below? I think it would be best to make our code team agnostic, and we could write a function called generate table or generate score chart or whatever this is, where you pass an argument in of the team. We pass Golden State in, we get this. If we pass Houston in, we would get the opposite as far as the colors. So we could try that. In the next video, we'll do the refactoring. We'll make it a little bit nicer. All right, so let's refactor this relatively ugly code. And even if we're not making it easier to look at and understand, let's make it more reusable. So I can make 2 different tables or 2 different ULs for each team with a different perspective. Or I could make this work with any data. It doesn't have to be hard-coded for Warriors, and I don't want to have to just duplicate this code to make another table or another UL with a bunch of LIs that we're calling a table. So the first thing I would do is just wrap it in a function. Let's define a function. I would probably call it like, make chart, like that, and then pass in the data. So I'm going to define my function. I'll go with const make chart equals a function that accepts game data or games. And then that will be an arrow function. It doesn't have to be, but that's fine. And I'll start by just putting all of this code inside the function. And the way I'll write my function is I won't have it actually append the chart. It will make the chart, but then I can append it wherever I want. By calling it, it will return the UL. Let's get rid of this extra console.log. So we're making this UL parent. At the end, we'll return UL parent, and that will contain all of the LIs, all of the data. And then I can simply append it or prepend at the end. So I'll make my variable, I'll call this chart1 equals make chart, and then document.body.prepend chart1. So I'm just moving it into a function. Now I could call this twice if I wanted to, assuming we don't have any errors, and it looks like we do. Data is not defined. I need to pass in the actual name of this. It's not called data, it's called Warriors Games. And then I do need to update my loop. Here the parameter is called games. So for let game of games, I don't want to hard code it to be this particular data structure. We want it to be whatever is passed in. And there we go. So now I could just make another table easily, just duplicate this code. It will be identical, but I now am able to do it twice. There we go. All right, so we've made our function slightly reusable, but now I want to break it up a little bit. This is still kind of, it's kind of a lot to do in here. So what I would probably break it into is a function to determine the interior, the inner text, this stuff right here. And I'll call that get content or get text, get scoreline maybe, equals function. We'll figure out what it accepts in just a moment. And I want to call it like this. If I have my li that I'm making right here, I want to call game li dot inner HTML equals get scoreline. And then I'll just pass in the entire game. So I'll move this content that is getting the destructuring home team and away team variables. This line that is making the team names, the away team at home team. I'll get the score line, the point stuff, all of this right here, cut it out and move it over here. And we're passing in the entire game. Where are you? Right here. And I'm going to destructure from that. I'll get the home team and the away team, which is what I did right here. But I'll just pass the entire game and destructure it here inside of the parameter definition. Okay, we need to make sure we return something. And what I want to return is this line right here. We'll walk through it in a moment. Okay, so we made this function called getScoreline. We pass in the entire game. it will extract or unpack home team and away team, and then further unpack H team, H points, A points. It creates the team names string, it creates the scoreline string, and it returns both of them combined into team names, scoreline, into one string. And that one string is returned from here, and I'm setting game.li.innerHTML. Game.li represents each li, each one of these. So I just wrote a function to generate this for me. And almost always, whenever we move stuff around and refactor into new functions, I'm sure we'll encounter something. Yep, what is it now? H team is not defined. And the line that is causing me trouble right now is right here. Warriors equals H team. Well, H team is gone. I moved it into this function. So what I would probably do is to start, just comment this logic out. Let's make sure our last version worked. Okay, so we are getting the correct text on the inside of each li. Now I'll probably make a function called getWinner or winning team or something like that. The way that I want this to work, I should be able to pass in the team that I'm making the table for. So Golden State, but I should also be able to do it for Houston instead. But I'll start with Golden State. So I will accept a parameter called target team. And then I want to check if for each game the winning team was target team. So if it was Golden State. So this stuff that I have here, I'm probably going to move into a new function, and I'll call that function, let's see, how would I want to call it? Maybe isWinner. And then I could pass in game and target team. Okay, so that doesn't exist. We'll define it. Const isWinner equals game target team arrow function, or just a regular function, and we'll check in that game. We will do the same thing we have here. So I'll just move this single line for now. Down here, we'll replace Golden State with target team, and I think I'll destructure the same way right here on game. So we get home team and away team. We're unpacking those values. So we're passing one game in, and we're passing in the string Golden State, for example. And all I want to do is find where Golden State is, if it's away or home, and check if they are winner, if isWinner is true. So I have home team, away team, and target team. I'll just check if home team dot team equals target team. If that's the case, let's make this a variable just called team target, and I'm going to return target dot isWinner. So this line is just to find the correct team, home team or away team. So I could have done away team.team equals target team, and then just set that to away team. Either way works. I'm just trying to identify target, which object actually has Warriors as the team. And then I'll return that object's winner, or isWinner property. And then here where I called it isWinner, I can use that now to decide the class. And I could put it right here, just do it in one line. We'll see how ugly it is or isn't. So we'll call isWinner for this one game with the target team. Let's say it's Golden State. If that returns true, we'll add win. If it returns false, we'll add loss. Is it going to work? We probably have some other bug. Oh, it seems like it worked. So let's try switching it around. This time, instead of looking for Golden State, let's look for Houston. Hey, it's working. So we can see Houston lost the first one, they won the second one, and so on. So we've now made this actually reusable, and we can have a different target team each time. So that's kind of all I want to do here. We've got our function makeChart. It has two other functions, getScoreline, isWinner. It doesn't have them, but it relies on them. And we can call makeChart multiple times. It does not append anything itself. It returns the chart element that we then append on our own. I could probably refactor this here. I'm okay with it, but we could take advantage of isWinner and just reuse that function. There are more ways we could refactor this, but it's already been a significant chunk of time here. So we're not going to go too crazy on this. We have lots of projects coming up, and you'll talk a lot about refactoring then. So I think this is good enough. The one thing I would do as we're displaying this is maybe add a title or two so we can see what's going on. Maybe in our index, I'll just add 2 sections. So the first one will have an H2 that says Warriors, or how about Golden State Warriors? And this section will have an ID maybe of GS. And then we'll have a second section with another H2. This one will be Houston Rockets. And the ID will be, I guess I'll just do Houston Rockets, GS and HR. Now I'll append my charts into here, and I'll have a heading for them, which will make it a little bit nicer to see what's what. So over here, I now can select those 2 elements. So I'll call this const Warriors section, maybe GS section, equals document.querySelector or document.getElementById. Use the hash sign for GS to get the ID of GS, and then I'll do Houston section equals document.querySelector. I don't want all, I just want query selector of HR. So I have those 2 sections. Now I can make my 2 charts. So we'll go with Golden State chart and Houston Rocket chart. And I'll change the target team to be Houston. And then instead of document.body.prepend, I'll do GS section dot append child this chart, the GS chart that we made with the perspective of Golden State Warriors. And then we'll do the Houston section dot append child, and we'll add in the HR chart. And let's see if that works. So we make 2 charts, one from each perspective, one looking at it from Golden State's point of view. We append that to the Golden State section that I added. Then we do the same thing for the Houston Rockets. That perspective, we pass in Houston, and we use that and append that chart that we get back to our Houston section. And I added some H2s so that we have some text to look at and we know which chart is which, and we're good to go. So that's it. It's a lot of work, but we are dynamically creating these charts here. They're not tables, it's just LIs, but we've got a couple elements we're creating. We've got bold tags, we've got LIs, we're adding classes, we're changing the inner HTML. We're using a ton of the stuff we've seen so far.